Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes the basic properties of binomial distributions. Let's get started. So, here we're going to introduce the binomial probability distribution, or we just simply call it a binomial distribution. It's a type of probability distribution. We're going to talk about the notation, methods for finding probability values, and essentially binomial distributions are for circumstances in which outcomes belong to one of two relevant categories. So it's black or white, win or lose, acceptable, defective, survive, died, these types of things where it's one or the other, you win or you lose, succeed or fail. That type of situation calls for binomial distribution. We're also going to consider other important characteristics of the distribution, including measures of center, variation, the spread of the values, that sort of thing. So what we're going to do is characterize the distribution with its mean, its variance, and its standard deviation. And what we want to do is be able to interpret and understand those values. Because any monkey can just calculate values, but what we're looking for is to understand what those values actually mean. So to start with, we need to understand the binomial probability distribution results from a procedure that meets all of these requirements. There are, just as there are requirements for distribution to be a probability distribution, so there are requirements for probability distribution to be a binomial distribution. So first up, we've got to have a fixed number of trials. Second, each of those trials must be independent. There's no dependency here, okay? The outcome of any one trial can't depend on the outcome of another trial because, see, that changes, as we've seen earlier, that changes how you calculate the probability for those trials. And we can't have that. We got to have trials that are independent so that the way we calculate the probability is not affected by any of the other trials. Each trial must have all outcomes classified into two categories. Typically, we refer to these two categories as success or failure. And you can define success any way you want, but how you define success will determine how you work the problem. So some definitions of success make the problem easier to work than other definitions of success. And sometimes those easier definitions of success are going to seem backwards. But, the more you get comfortable working these types of problems, the more you begin to see just how to define success so that it's easier for you to get the answer out that you need. And fourth, the probability of a success must remain the same in all trials. That's an assumption we're making with the binomial probability distribution. So we have to meet all four of these requirements. If any one of the four is not met, then that probability distribution is not a binomial distribution. Let's run through some notation of the probability distribution to get familiar with what we're going to be looking at. So we're going to use the lowercase letter n to denote the number of fixed trials. This is going to be discrete data. It's going to be a whole number. The letter x is going to be our random variable, and it will denote a specific number of successes in those n trials. So, x is also going to be a whole number because we're counting the number of trials. And there's no such thing as a partial trial, so, it's like the trial is a success or it's a failure. So, with the way we've defined this, the value of x is going to be somewhere between 0 and n inclusive. Capital letters S and F will denote success and failure. The lowercase letters P and Q will denote the probabilities of success and failure, respectively, in any one of our n trials. And because this is a binomial distribution, one of those requirements is that probability for success has to be the same for each trial. It then follows that the probability of failure has to be the same for each of those trials. So everything's either a success or a failure, so each of those probabilities has to add up to be 1 because you can't be, there's no other option. You're one or the other. So the probability of X is the probability of getting exactly n successes among n trials. And this is the equation that we use to describe the binomial probability distribution. Let's take a closer look at this equation to understand what each of the different parts means so we know what it is we're going to be working with. So this first part of the equation is the number of outcomes with exactly X successes among n trials. Now, if you look closely enough at this portion of the equation, this portion should seem familiar to you. We have seen this portion before. Remember when we were calculating combinations? This is the same equation that was used to calculate combinations. And this is what's giving us the number of outcomes with exactly X successes among n trials. You could say it's n trials taken X at a time. Same sort of calculation here. This next part of the equation is the probability of X successes among n trials. Remember that we've got P is the probability of success. We're raising that to the X power because X is the number of successes among our n trials. So we're going to calculate the probability that each of those trials is successful comes out that way. And then this final part of the equation is the probability of the number of failures among n trials. So of course everything's either a success or a failure, so you're going to be looking at X number of successes would then mean n minus X number of failures. We just subtract the number of successes from the total number of trials, and that gives us the total number of failures among our trials. And we're taking that probability of failure and raising it to the power of the number of failures among our trials. So these are the different parts of our binomial distribution. When we multiply them together, that gives us the probability of exactly X successes among n trials. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.